Chapter 14. Chemical Effects of Electric Current.
Introduction.
When you were small, did your parents tell you not to touch electric switches with wet hands? This advice is given to every child. Surely, you can guess why. You might get a shock if you touched wet hands to a switch. Why does that happen? Conductors and insulators. In the last chapter, we learned about static electricity and how it is generated. When two objects are rubbed, one gets positively charged by losing electrons and the other gets negatively charged by gaining electrons. When an object gains a positive or negative charge, it does not stay charged for a long time. It loses the charge quickly by interacting with its surrounding and becomes neutral again by gaining or losing electrons. There are some materials which allow the electrons to pass through them, while there are others which do not. Based on their ability to let electrons pass through, there are three types of materials. 1. Conductors. These are materials that allow the electrons to pass through them. Metals are good conductors. The outermost electrons in metal atoms are loosely bound and can move freely. The movement of these electrons generate current. There are some other substances like air, water, soil, non-metals, etc., which do not conduct very well. They conduct current under special conditions. These are called poor conductors. 2. Insulators. Some materials like rubber, glass, plastics, etc. do not conduct at all. This is because their electrons are tightly bound within the atoms. Such substances are called insulators or bad conductors. However, these materials can generate static electricity by rubbing against another surface. 3. Semiconductors. There are few elements which have properties of both metals and non-metals. They are poor conductors of current at low temperatures but can become better conductors at higher temperature or by mixing with another suitable element. These are called semiconductors. Usually, in an electric cable, the metal wire inside the conductor of current, whereas the outer rubber coating on the wire is the insulator. In class 6, you made a circuit to check whether a substance is a good conductor or a bad conductor. Let us do it again. In the early days of experiments on electricity, scientists thought that positive charge moves from a positive terminal to a negative terminal. Later, it was established that electrons travel in the circuit. However, till date, the direction of flow of current is taken as flowing from a positive to a negative terminal in a circuit. Can liquids conduct? You can repeat the circuit used in circuit test activity to check whether liquids are good conductors. From the above activities, we can conclude that all liquids are not good conductors. Most of the liquids that conduct current are solutions of acids, bases, or salts. A salt is formed by the reaction of an acid with a base. Solutions of acids, bases, and salts in water contain charged particles called ions. Ions are atoms or group of atoms carrying positive or negative charge. Positively charged ions are called cations and negatively charged ions are called anions. Movement of these ions in a solution makes it a good conductor. A liquid which can conduct electricity is called an electrolyte. Hydrochloride acid, sulfuric acid, sodium hydroxide solution, copper sulfate solutions, etc. are examples of electrolytes. Remember, an electrolyte solution will always have ions present in it.
Chemical effects of current. When the electric current passes through an electrolyte, a chemical change occurs. This may include formation of a gas or a solid metal or a simple color change in the solution. This usually happens because when current passes through an electrolyte solution, it tends to decompose the electrolyte particles into simple substances. The products of this type of chemical change depend upon the electrolyte and the electrodes used. The process in which an electrolyte undergoes a change on passing current through it is called electrolysis.
Electrolysis has many applications in industry. It is used to obtain reactive metals like sodium, potassium, and aluminium from their ores. It is also used to purify certain impure metals.
Electrorefining of copper. Electrorefining of copper is done by making a cell as follows. Copper sulfate solution is used as electrolyte. A pure strip of copper is connected by wire to the negative terminal of a battery. A bigger piece of impure copper metal is connected to the positive terminal of the battery. When the current is passed, the impure copper dissolves into the solution and pure copper starts depositing on the strip of copper. The impurities remain in the solution. Gradually, all copper from impure copper dissolves and deposits on the pure copper strip. Electroplating. This is another application of electrolysis. In this process, a layer of one metal is deposited on the other. For example, an iron object can be coated with a layer of zinc to protect it from rusting. Sometimes, metal statues are coated with a layer of chromium to make them look more shiny and attractive.
In a similar way, jewelry makers make gold-plated jewelries. Jewelry made of cheaper metals is electroplated with a layer of gold. This is much cheaper than the jewelry made of pure gold. Similarly, metal decoration pieces and bicycle handles are electroplated to look shiny and attractive. Cans used for storing food are made of iron but coated with tin to prevent rusting. Iron used in construction work is coated with a layer of zinc to prevent its rusting. However, the waste solutions left after the electroplating are highly hazardous and need to be treated carefully before disposing them off. For this reason, electroplating industries are set away from the residential areas.